This lesson is on finding the equation of the tangent line at a given endpoint value. So you'll be given a function, and this is a quadratic function, and you'll have to find the derivative. Now at this point, we are still finding the derivative the long way. So the derivative is defined to be the limit as h approaches 0 of f of x plus h minus f of x over h. We call that the difference quotient. So if we break this up, first thing we want to do is find the difference quotient. So we'll find f of x plus h first. So that would be 2 times x plus h quantity squared minus 3 times x plus h plus 5, which you'd have to expand this binomial first. So that's x squared plus 2xh plus h squared. I like to use my square double square shortcut, where I take this x, square it, multiply these two together, and double that so it becomes 2xh, and then square that h. Square double square. I'm going to distribute this minus 3, and then I'm going to distribute the 2 to get 2x squared plus 4xh plus 2h squared minus 3x minus 3h plus 5. Now when you expand a quadratic using by putting x plus h in, you'll always get this long string where there are no like terms. Okay, so the next step, I'm going to subtract f of x. So I like to subtract f of x by adding the opposite. So here's f of x. So I'm going to write down negative 2x squared, and then positive 3x, and then negative 5. So essentially what I've done is distributed the negative. Now I can use my adding rules, and they cancel, and I'm left with 4xh plus 2h squared minus 3h. So the third step is to divide by h, and my difference quotient will be 4xh divided by h is 4x, 2h squared divided by h is 2h, negative 3h divided by h is negative 3. And so that's my difference quotient. So the next thing I have to do is use the definition of derivative using the limit definition. The derivative is equal to the limit as h approaches 0 of the difference quotient, which we found to be 4x plus 2h minus 3. Now I can evaluate, because when I put 0 in for h, that's fine to do. You get 0. So the limit as h approaches 0 of 4x plus 2h minus 3 is 4x minus 3. So that is the derivative. Now, to find the equation of the tangent line, I always say you need a point at x equals 2, and you need the slope at x equals 2. So to find the point, you're going to use the original function f of x and evaluate it at 2. So that would be 2 times 2 squared minus 3 times 2 plus 5. So that would give you 2 squared is 4 times 2 is 8 minus 6 plus 5, and then you would get 7. So we have a point, 2, 7. Now I need the slope. So the slope is the derivative evaluated at that same x equals 2. So there's my derivative, 4x minus 3. So 4 times 2 minus 3 gives me 5. So that is my slope. So now I have a point and I have a slope. And I like to use the point-slope formula. The point-slope formula is when you're given a point and a slope, you can plug it in to that formula. The y1 is the y coordinate of the point, and the x1 is the x coordinate of the point, and the m is the slope. The y and the x are going to just stay y and x. So here's my x1, there's my y1. So this is going to be y minus 7 equals my slope, which is 5, parentheses x minus 2. So y minus 7 equals 5x minus 10. So you distribute, and then if you add 7 to solve for y, you get y equals 5x minus 3. So this is the equation of the tangent line at a given point. If I were to sketch this out, what it would look like, just very quickly and roughly, this quadratic way up here has a y-intercept of 5 and an x vertex around here. So it looks something like that. And at 2, 7, somewhere right here, you have this slope of the tangent line. Tangent meaning it only crosses at one point. So that's a very rough sketch, but this is the point 2, 7 in this equation. This line here has a slope of 5 right here. Okay, I wanted to do one more example with some different variables so you can see how that's handled. This is a P of Q equals 20 minus Q squared is our function, and we want to find the equation of the tangent line at Q equals 1. Reminder that the derivative definition is the output is P, the input is Q, so the derivative of P prime of Q is equal to the limit as H. H is the distance between the two x coordinates, so this H stays H. As H approaches 0, of P of Q plus H minus P of Q. So instead of x here, we have q, and instead of f here, we have p. So that is the definition of derivative. So I have to find p of q plus h by plugging q plus h in for q. I put the understood -1 here, so 20 minus 1, and then again I'm going to square, double square. I'm going to expand q plus h. That means q plus h times q plus h. That'll give you q squared if I'm just square the q. And if I multiply QH together, I get QH. Double that, I get 2QH. And then square the H. So that's my shortcut method, square, double square. Now I have to distribute the -1. So that's 20 minus 1Q squared minus 2QH minus 1H squared. Now I'm going to subtract P of Q by doing the opposite. So 20 would be -20, and negative Q squared would be positive Q squared. They cancel, and I'm left with negative QH minus 1H squared. Next step, divide by H, and I get negative Q minus H. So then I can find the derivative. P prime of Q is equal to the limit as H approaches 0 of the difference quotient. I can go ahead and put 0 in for H, and I get negative 2Q is my derivative. So now I need a point. So I'm going to use the original function to find the point, and I'm going to use the derivative to find the slope. So P of Q equals 20 minus Q squared. That means that P of 1 would be 20 minus 1 squared, which is 19. So my point is 119. My slope, I'm going to use the derivative. So P prime of 1 would be -2 times 1, or -2. That's my slope. Now I'm going to use point slope form, which is y minus y1 equals m times x minus x1. So that would be y minus 19 equals -2 times x minus 1. Y minus 19 equals -2x plus 2. Add 19 to both sides. I'm going to get y equals -2x plus 21. So that is my equation of the tangent line at x equals 1.